Hello, everyone. Uh, I would introduce myself to you. My name is Qusai. I'm an electrical engineer with a background of control systems, and I originally come from Saudi Arabia. So I've been here in the US for about 3 years, and I'd say it's a very good accomplishment for me to reach this point with my education and having this opportunity to work on the senior design with you guys. And I'm really glad to be here with you guys. So, once I've been assigned two teams in here, I was assigned to a couple teams, either the power and navigation. And my main focus, since I'm the only electrical engineer here, is that I need to work a lot with whatever parts and schematics whatever parts that we need to implement over the robot, since it's an unmanned kind of machine. And this is the basic schematic, and I had this from the technical report of the previous ECEs. And these are most of all the parts that we need to implement on the robot somehow with their certain connections. So first of all, the most concerned thing is we have the laptop, which is going to control everything, and that's connected to what's called the PCB, and that's the printed circuit board. And this circuit have gained some power from the batteries, and with some converters, it delivers that to all parts that have been connected to the PCB. So everything is supposed to be connected to the PCB, and from that, it should be controlled by the laptop. And we have everything, so the camera, the navigation system, the LRF, the motors, and whatever we need. These are the basic kind of like schematic of how much power should be distributed over for all the parts. And as we can see, we have some. This is like the biggest section is that we need 48 volts to the motors, and then we need 24 volts for the LEDs, and the 12 volts goes, and that's like the biggest chunk of whatever the battery is powering is all these parts. And we're talking about the LRF, the camera, the network router. We're talking about the navigation stuff. The Arduino board, which is like the Arduino board and the digital compass. These two are very small circuit that has they are a little bit more sensitive, and they cannot work with higher voltages. And so the Arduino board is the one that we might implement the light sensor from the vision team. That's the kind of board that we need to work with, and it's going to be like a different circuit from the one we had as the main circuit. And what I've been working on since I've been here, so I've been here for like 3 weeks now. First of all, I had to take a look over all the batteries and how they've been connected and how we've been able to power the robot in the first place. And that's like, this would be like my most essential task in this team. So what I understood, and it's really important that everyone understands this, just for sake of knowing how we're powering this, is that we have these bags of batteries, and every bag of batteries is built out of 4 sets of smaller bags of batteries. Every set is built out of 4 what's called the lithium polymer batteries, and the total voltage of this battery is about 60 volts. That's the max that we can have. And we all know that at the range of 40 volts, when it drops to the 40 volts, and that's a very dangerous, it's a very dangerous mark where everything would shut down just if it reaches the 40 volt. And that's saying we still have so much power in here but why it reached the 40 volt mark, and why everything's shutting down at this point and not lower than that, that's a very, this is what I've been working on. I couldn't understand that, I couldn't figure out it. But I'm still working on how can I fix this. And a little bit, I will show you the new circuit. This is pretty much how, okay. Yeah, and this is the circuit that I've connected to the batteries. This is what's called voltage regulator kind of thing. I had this just to give an understanding how actually lithium batteries how lithium batteries work. They're basically like some layers of different polymers of lithium and carbon and other stuff. And the lithium is a very reactive kind of material, and that's how like when we charge it with so many electrons, with so much energy, and when we lift it up, when we take off like the energy source and we suck the energy out of the lithium, the reaction of breaking the bonds will get us the much power that we need. So right now, the next task I've been working on, like since I had the batteries on the side for a little bit, is understanding the new PCB. And what is this is that we had the huge circuit that was in front of the Raven and the Scorpion. And instead of that, the previous ECEs, and I believe those the ones who came last semester or last year, not way before that. So we're gonna be the first team who's gonna work with this new augmented circuit. And this circuit is recently designed and recently built here on last semester, and they've been using a software that I couldn't get access to until like a couple days ago, and that was holding me behind. And the next task that I need to do is that we need to connect every single part of the things that we need to implement on the new platform on this circuit, and that would be like everything I had for the power section. And after that, since I'm obligated to work a little bit with the navigation, so I had to meet with Torrance, and I never had much time to sit with Derek. I've been barely understanding how the lab view is working out, how we set up the master VI, and how we set up the thing. I've been out with him for a task where we've been able to actually connect to like about 7 satellites, and that was kind of like interesting. And what is navigation and what we're trying to do is basically like we're going to have some waypoints once we get to the open field that we need to go through these waypoints with a little bit working with cognition, with the vision team, so we can go through obstacles and stuff. And how essential is the navigation to our system would be? We would only say that we can set the mark points where we want the robot to go. So basically, the robot is just a machine. So it's a thing that we can tell it some kind of instructions to go out in the blinds to a certain places. So with the power of finding the obstacles and going through the things, that's the thing that we've been all concerned about so far. But I was having this kind of idea, like we're gonna have different heats, and every heat we have different fronts. So how can the robot be a little bit smarter every single time than the run before it? And Torrance was working on this technique that if we have in a robot to walk in a certain place and it has a little bit of struggle of going through this point, and we would mark this point and we take average of whatever points been recorded in that place. So the next run would be a little bit smoother since I'm going to record this one, I'm going to record this one. So the robot would have a little bit smoother kind of path as it's been going through the field with different fronts. I have an idea that I want to present to all of you guys. So I've been asking about this, but I didn't see it yet. So basically, if what I want to present is that why can't we like find kind of a navigation kind of mapping for the whole field for whatever the robot's going through? So I was thinking about this. If we've been able to track the robot for every single point as it's going through the thing, and I wanted to add this, but I couldn't. I don't know. So we had the histogram that shows where the robot is going through the path with the kind of like the navigation that comes out of the satellite. Okay. So if we've been able to kind of record everything that's on the field, so the robot will start out of this section, it will go through these barrels, so we have these lines, and we have the path for it. If we've been able to kind of record, I can record the path with a navigation kind of system, and I can record the obstacles as kind of like danger zones or kind of like red lines that should not be crossed. And as I'm going through for the first one, I still have the histogram. With the same technique that Torrance presented to me, is that we can, essentially what I want to take what he presented to the next level, is that instead of just taking the waypoints where the robot is going to kind of like be like initially struggling, initially needs to understand this is a very difficult spot, and it needs a little bit more, not calibration, it's a little bit I don't know, more efficient kind of way to approach this one. And I was thinking, why can't we like record everything in the field? We can work with the either with the vision, with the cognition and the LRS. Everything that's going on the way of the robot is basically can be recognized by the robot. So if I can mark that by a certain way and I can design that with kind of navigation kind of mapping, we'll have a robot that goes for the first run going away in a plane, but in the second run it will have some kind of map that's going through without even the struggle, without even needing much effort of the different sensors and the different things. And again, what I need to like kind of concentrate on for the time being is that I really by the end of next week, and that's the thing Daniel been talking about. We need to actually have the new platform, the BlackBerry to be ready in about like 2 or 3 weeks from now. And I would say this is the very most essential thing I need to work on. So I have the robot ready and powered up with all the cables and the stuff needed by the end of next week, hopefully. And and I will concentrate my work after that with Derek and Torrance and the navigation team. And that's pretty much what I have today. And I really want to like open this for discussion, like the idea of having if we are actually being able to map everything or not. This would not be an easy task for us to do in the time being, but I believe like everything is under development. You never know in the future what we asking, what we needed to do. Like if we can figure out a way to map all the obstacles in the way, that would have many different applications. And I didn't see that anybody worked on this or anybody like had this in mind before. Like I cannot ask around for it. And that's what I have so far. And thank you guys for listening. Any questions? Yeah.
You said that you wanted to record the obstacles in your path. Can you record them from run to run?
Yes.
They can change obstacles.
Correct. I understand that, but here's the thing: there are some certain things that cannot be changed. So we cannot change the path. If we can record the bath is going to be visioned by the cameras and stuff. If we can record the bath, so I basically can tell the robot, okay, the first run, you're going to record all this, and I believe Chris is working also on how we never miss those lines. If I can navigate those and get my robot in a certain distance in between those lines, that's a thing will help the robot for the next and the third run, and it would even help it with across the whole test. But the obstacles will be changing, so we can work out this kind of like, just that.
Before this next question, I want to clarify what Mahmoud was just saying. The obstacle will not be changed during the heat between runs. So it's safe to say that, things will stay as they are during the heat. So if I'm not saying that, I totally support the concept here. I'm saying that, if you really wanted to record something and turn that into, if we can do that, we turn that into something useful, that something useful will be staying good, within the heat. Okay? And then the next heat, then, obviously they're going to be changing the running direction now from clockwise to counterclockwise. Then obviously, you're going to have to, memorize a new map, right? So, back to you, then Jesse.
So I think we talked to you a lot about navigation, but we already started doing the path, recording path with intermediate waypoints. And if you have ideas for that we can implement with this program, because I started writing it last semester, then I'd be happy to. I just didn't know if you were jumping between. I know you're jumping between electrical and navigation.
Exactly.
I didn't really have enough time to spend with you besides moving it out. So I'll show you my code, and then if you have any ideas or if you have any if you want to say something, right? If you have any ideas that you can implement, that'd be great.
Cool.
So when you said earlier you were able to more to Torrance.
Yeah, I never had much time to talk at Derek at all. Derek, the last 2 meetings he were like not around. So.
It's not that Derek tried to not make himself available to you. Or
yeah.
I like that.
No.
It's still money too.
Yeah. That's all I'm not around.
Because if you did that, I'm gonna have to replace him. For someone who needs it. Okay.
Yes.
Yeah, I was gonna say that too. Navigation. I knew navigation had something to do with that with the intermediate waypoints. We also in Cognition's VI, the main way that the robot guides its path is through what we call the local map. When it takes in all the information of what obstacles it sees in front of it, that is the local map, and that's how it guides, how it determines where it is and where it should want to go. We also have something called the global map, which is in the VI, but I don't believe is being actively used when the robot's running. And that is like the local map is the instantaneous what it sees, and that changes every time the whole program loops. That's changing constantly. That's how fast the global map is supposedly building all that information.
It's a lot of memory though.
It
I
does.
mean, we turn it off because if the robot's running and we're not watching the screen, there's no point in having it play because it takes up a lot of.
Well, here's my method. It's like we need to record this. We need to implement some kind of code that records this data and connect it even with navigation. And the navigation data would come. It's more helpful with that. And if we can memorize that with the robot and make it like some kind of like implement that the data that being stored for the next one, you would have a very smarter robot than whatever's going to be there in the competition.
I agree with what you're saying because I had the same thought when I first started learning how the robot finds its path, because that the advantage that I saw to that was that instead of the robot constantly rediscovering every obstacle and falling around it, if we have some sort of memory, just having a layout of where the robot sees itself relative to everything else that it remembers around it seemed like a good way to plot the path also.
Correct.
But and that might be, if that could be developed, it would involve a lot of changes in how the robot plots its path. But something else we need to keep in mind is if we're constantly keeping a record of where the robot has been, what the robot has seen, then say on the next one when we go to use that map, we have to keep in mind error checking to make sure that map is correct. Because if we just start going by that, map and it's off a little bit, then we can run into trouble. So we need to not only be building that map, but also somehow verifying it at the same time, which might end up using a lot of the same functions we're using now.
The same data that is covered, correct?
And then also, I forgot what it was.
You're as old as I am, right? You're as old as I am. I don't remember anything anymore now.
Any other questions?
Just based on your conversations over here. First of all, if you try to map out the entire course and the field, that's tremendous. I don't think, our laptop would have that capacity to do this. However, I think, this conversation here really, we're going to need you. What is that? You're going to be the key answer to this. Right. But relate to her anyway, right? I think the only possibility is I'm not objecting to this idea, but I'm going to compromise this. The idea is this. I think the only place that this could be happening, to kind of memorizing some global landmark, if you will. By landmark, it could be actual obstacles, it could be the coordinates, the GPS coordinates whatsoever, right? I think this can be done between only navigation and simulation. You see, simulation is great, right? I mean, talk about it at the competition, but then the judge is going to immediately bring the question to you to say, so how the simulation is helping out with the actual implementation? If there's no connection there, then our simulation will be graded not here, but here. Making sense to you? Meaning that there's no connection between, what are you guys trying to make so much effort between simulation and your implementation? There's no connection there, then this simulation effort is, doesn't work as much. So that's the whole point. So I think, the only thing that could make this happen here, that would be a new task for you, Derek. You're whoever's going to be focused on this. That someone needs to be working closely with simulation to make that happen. So that you're not only recording your intermediate points, but turn those intermediate waypoints all the way throughout the entire course. So you have the key waypoints, if you will, to basically guide the vehicle from one waypoint to to the next key waypoint. In between, as Jesse said, that even from time to time, that not intentionally, that the judges will be rearrange all these obstacles. Not that would not happen purposely, intentionally between heats, right? Between heats. But occasionally, this previous vehicle bumped into the obstacle, so it changed that just a little bit here and there and here and there, right? So all that detail we cannot map. All that detail change we cannot map. However, the cognition should take care of all the local navigation anyway. So under that, how do I say it? You have the major global navigation going on based on your simulation and whatever the intermediate waypoints. But in the meantime, you always have that cognition running in the background. You check, in real time to say, am I safe? If not, then I better make a small modification there. As long as I'm able to cover this waypoint and the next major waypoint, I'm safe. And that would provide this additional guideline or intelligence to the vehicle, so that our run will be finished in much shorter time. And that will be a record. And suppose Naval Academy, who is really our next contender, who's just right behind us for the 2 years in a row, right? When it comes to the auto navigation, we're always the first place, and they are the second. And who knows, they had a major breakthrough this year, and they will be really competing with us this year. And so if both teams will be completing this course and completing the flag section, if we both succeeded, guess what? Whoever make it in a short amount of time will be the winner. So saving time would be very much a desire. So that's my proposal. So that's where I think that I don't see that trying to incorporate all this information in real time, with cognition, navigation, vision, and all that, and try to map that. I don't think that's going to work. It's just too much data, too much computation intensity that's going to be needed or provided.
But if you allow me, Professor, I believe this is going to be the next stage for the robot that we can get to. Like, if we can map everything and work with it simultaneously, that means the robot will have this amazing kind of performance.
Yes. But make that next year's major task. We only have 10 weeks left. So we got to focus on what is working and what is available for us, and it's really working now. So the only thing that I would suggest here is to have a compromised version. That is to have simulation working with navigation closely to provide that kind of information. So it's more on the global navigation rather than the local navigation. That's my suggestion. All right.
Any questions about the circuits, about the borrowing?
If you go back to your first slide, more or less, the second slide is right there. Yeah, you can drop this down. There's one time we had a plan to use a LiDAR provided by. Oh, now I remember that lab in the cinema. Comes back to me. Strobe lab. Anyone has any friends or working there? It's called Strobe lab, and it was purchased by Boeing. So now it's part of a Boeing facility. But this is the company that actually developed a LiDAR, and they were going to provide that to us if we develop the value driver to read all the images. But it didn't happen because they were too protected of their device. They didn't want to loan this to us so that we can really develop the software for them. And then it just fell through. So at that point, we just decided that we don't have this. There's no 24 volts DC-DC converter, and there's no LiDAR.
I noticed there's nothing in the circuit.
Right. Well, 6 years are going to be wired this, so instead of having you looking for that. Okay. Derek, can you update us on the status of navigation?
Navigation?
Yeah. What is I know you got Torrens, you got resolve, and half of the wheel, right? And now you got wheels. You got two George guys who supposed to be working from you as well. Right? And then once you finish all the wiring connections, then he may be working with you as well. Number one, I need to know the status. Number one, where's your plan for these guys?
So navigation is working. The plan for Torrance and Will right now is going to be mainly focusing on the flag detections to make sure that it works. But we tested it last Thursday. Yeah, we tested it last Thursday and it works. So when it was in the range of, we changed it to about 3 meters. It will turn on, and if it left that range, it turn off. And so then I guess it's Sunday they tested it again, and there was a problem with it. So we're going to double check that again to make sure that flag detection is still working. After that, because it seems like we did it once on Thursday that it's a quick fix, then Torrance and I are going to start working on intermediate waypoints, and I'm going to have Q come in with some of his suggestions and work on that. Other than that, right now navigation is up and running. It runs forward and backwards, so north and south. And right now it logs waypoints through intermediate waypoints. We just need to. Torrance had ideas that we want to implement, and Q was just talking about some ideas that we want to implement too, just like building a path. Maybe we can't do everything, such as mapping boundaries and all that stuff. What we can take one step forward and try to see if we can. There are any smaller ideas that we can implement.
Okay. Now you said that you succeeded with a 3 meter range.
Yes.
Okay, 3 meter is about 9 feet.
Yeah.
And if you based on 5 miles per hour, the vehicle,
yeah,
which is 7 point some feet per second. So you're talking about allowing within about less than 2 seconds.
Oh, what we tested was
to turn on that flag
yes.
detection flag.
Yes.
So is that too short for you?
No. We just tested at 3 meters because we didn't have enough space to test it because we finally got
the campus too small.
Yeah, we just had a smaller campus. We just tested out on the sidewalk here. So instead of keeping it at 11, we actually switched it to 9.
I just want to see if the DI work for you.
If we have control over the range of that.
Okay. You gotta
Oh yeah, we're gonna test it longer. We're gonna test out in the field, but we just wanted to make sure because we had like 15 minutes left and we got it.
Normally at 11 meters.
Yeah.
Okay. All right. Okay. So I just hope that you're still thinking about if you have a plan for all this new members and make sure that they're up to speed.
Yes.
Well, right? Okay. The plan is to by the end of the next week that the whole thing will be the whole vehicle will be ready to run, right? Do you need help? Between the two of you? Because trust me, even for wiring, we got one person who did the whole thing. It's an ECE guy who did this whole thing for us by himself. Because that semester we only have one ECE person, and it so happened that he's the one that actually completed this whole thing. It took much longer. He's an outstanding student, by the way. But it took longer than I anticipated, or than what he anticipated, to finish up all this connection properly and correctly. So I just want to make sure that you need help. Anyone in the group here can actually lend a hand to help you guys. So just let us know.
Yeah. By the end of next meeting, I will have the plan ready for the wiring circuit and powering everything. And hopefully by the end of Sunday night, I'm even planning to spend the whole Sunday in here wiring the robot and doing the thing. And hopefully by the end of Sunday, it will be ready. So at least all the wiring, the first test of the batteries and connection and stuff. And hopefully the next week, like after Sunday, everybody would be ready to connect their thing and start testing on the Black Web.
Okay.
I plan on starting on Thursday because it is a lot to do.
Yeah.
So I think we're going to start on Thursday so that when Sunday comes, we have very little to do so that we can actually get it working.
Okay, that's the thing. I have a midterm on Thursday. I would like have everything ready, but I cannot work on Thursday. So I would like spend some time studying more than working. But on Sunday, I'll be free. I'll be here like on Saturday. It's at 7, right after we finish the meeting. Couple hours.
Thursday, is it?
Yeah. On Thursday at 7. At 5, what? Like it's at 5 or at 7, something.
Sure. I mean,
But Thursday I had a midterm, so I
midterm
cannot
is
spend so much
certainly more
time.
important than this.
Yeah. So I wouldn't start the thing and start on. I'd rather start on Sunday. I finish everything on Sunday. I can even start on like.
Are you going to be in class on Thursday?
Yeah. Not the time of the meeting. You didn't get me. Like I didn't want to start the wiring and stop whatever I'm doing and then go back to the test and come back on Sunday. No, I would rather start and finish everything all at once. And what I'm gonna do on next Thursday is that I'm gonna see how much wiring I need, how much do I have all the hubs, or do I have all the serine, do I have everything that I need to connect? So I'd have everything ready as like a workstation, and then we do it next week. That's why I cannot organize.
I think we need to work this plan.
Yeah, it's like something between you and me. I'll decide.
And also, it's not just connection, but once you have connected the sensors, all these sensors require very specific knowledge of all these different groups to at least initiate or maybe test, right? You got to initialize some of these sensors.
That's what I want to spend all day Sunday doing, because I know.
Including the motors, right?
Yes.
Including the motor needs to be initialized properly and all that.
I know it's
when you
not
first
just
connect it,
let's plug it in.
Yeah.
There's a lot more to it. So that's why
there's just a lot more to it.
all that.
So what I'll suggest here is that, plan this out, including the need of getting some of those software group who knows how to initialize and test the sensor to be with you at a certain time. So book them ahead of time so that they will be there for you guys. But that basically says, you're going to need to have connection completed before they come in and test the sensor.
Right, which is why my goal is Thursday.
Yeah.
So that it is all wired up, and then we just got to do all that integration on Sunday. So we'll have to talk about it.
We'll talk about it more.
Is Friday or Saturday possible for you guys?
Possible for me?
I can't do Friday. I can do Saturday morning.
So I guess you have to really work out this detail. Yeah. And make sure that some of the sensors, in this case, I guess Derek, should know enough to test your part, right? And for the laser, who should be the person now?
Either Margaret or
Okay. And then the vision, the camera.
Vision's got to be right.
So you can do GPS and digital compass, both, right?
And then I'd like Jesse for the motor.
Yeah. Especially, I know that motor is going to need to be initialized first time connected to the controller. You got to do that before you can even power it up. And then we're going to need to have one person who is somewhat familiar with the pinout for the e-stop. We cannot, run the e-stop. We'll have the vehicle bump into something. Somebody needs to know. I have the configuration that I can provide for you guys, but your connection.
The e-stop is good to go. The only thing I'm waiting on is so the actual wireless portion of the e-stop is 4 connections, 2 for communication, 2 for power. And I don't have the male pins because we ordered that last week, so they should be in this week. And then I'll be able to make that power cable for the wireless e-stop, so it has power to all wireless.
I'm not talking about that. I'm talking about not the connection there you were talking about. I'm talking about the pin goes to the proper breakout for the controller, the nugget. And then the software, there's a software that, that allow you to test whether that e-stop is working properly. And then once that is tested, then we know when you run the actual lab UBI with this e-stop, that thing will work well.
Okay. Yeah, I copied the wires exactly from the previous platform.
So I try to remember to provide that sheet to you guys. There's a certain connection that needs to make it happen. So, okay, so that's another area. So the motor, e-stop, and all the sensors, right? So I have someone who knows how to turn it on, how to make it happen, available to you as well.
There's a thing that I'm thinking about for the batteries. Like it's really like it doesn't make sense for me. It's like when we got to the 40 volts, everything shuts down. Okay, that's a thing like relatively connected to the voltage converters, and since we only have two fuses and we only have two lines to whatever we're gonna connect to this. So I'm really thinking about a way that the way the battery is being connected, to the converters. I'm really thinking about like developing some kind of thing that I would connect the converter to this line differently from this line. This thing would crush the idea of having 40 volts to shut down the whole system. 40 volts is too much, and whatever like all these kind of small devices, like 20 volts is more than enough to work them for hours. And having 60 volts.
No. I was thinking that the 40 volts really is set by the PCM, right?
Well,
and the purpose of that is that the lithium polymer shouldn't be running that at a lower voltage because that actually deteriorates.
Well, I understand. I'm thinking of creating new batteries.
Yeah.
It's like I'm thinking about why do I need those batteries and why do I need to connect it to the PCB by this thing? So this thing was developed like for before. I want to develop a new circuit in the first place. Like I think this idea, like this, like when they design the circuit, so this design is like the most efficient so far.
Okay.
But following the circuit with the same ports from here, it's really not good.
Let's talk about that. But we gotta make sure that everything is gonna be ready by next Wednesday.
Whatever we have so far on this, we'll be ready by the end of next.
Right.
If I'm gonna do something new, I'm gonna design something new. I'll
okay. Yeah, that's fine. All right. Thank you, guys. So somebody talk to, or maybe Derek, you should talk to Melissa about this idea that we were talking about. Mapping.
So we're not really waiting.